Particle m is moving along a straight line PQ with a constant acceleration of 2 meters per second. At time t equals 0, m is at the point P, moving with velocity 6 towards Q. Find an expression for the velocity of m at time t seconds. Show that the displacement of m from P at time t seconds is t squared plus 6t meters. A second particle n is moving along PQ. The acceleration of n at time t seconds is 6t meters per second. At time t equals 0, n is stationary at the point P. Find an expression for the velocity of n at time t seconds. Find an expression for the displacement of n from P at time t seconds. Find the distance between m and n at time t equals 5 seconds. Find the value of t is greater than 0, when the two particles meet. So that's the question then. Quite a long question, so I split it up into the two parts. So we'll do this first section at the beginning then. Straight line with constant acceleration. So here, acceleration, which is dv dt, isn't it, is equal to 2. And at time t equals 0, v is equal to 6. And it's moving towards PQ. Okay, so A. So for the velocity, so if the acceleration is here, the velocity integrating with respect to t both sides, v is equal to 2t plus k. Imposing the initial conditions, so 6 is equal to 2t, which is 0, plus k. That tells us that k equals 6. So the expression for the velocity then, in part A, v is equal to 2t plus 6. And then show that the displacement of m from P at time t is 6 meters, t squared plus 6t meters. So here, part B, so s, integrate the velocity, you get the distance. 2, integrate with respect to t squared over 2 plus 6t plus k dashed, another constant of integration rather. So that tells us then that s is equal to t squared plus 6t plus k dashed. Now, what does it say? At time t equals 0, m is at P. Okay, so there's no displacement at time t equals 0. So t equals 0, s equals 0 gives. So we get s is 0, t is 0, 0 plus 0, plus k dashed. So k dashed then is equal to 0. So s, the displacement then, is equal to t squared plus 6t, which is what we wanted to show. Oops. There we go. A second particle, that's part B. Second particle n is moving along PQ. The acceleration of n at time t is 6t. Okay. So the acceleration is equal to dv dt, isn't it? Is equal to 6t. So that tells us the velocity is equal to raise the power by 1, 6t squared, divide by that number, plus a constant of integration, capital K. At time t equals 0, n is stationary at P. PQ, the acceleration of n at time t is 6t. At time t equals 0, n is stationary at P. Find the velocity of n at time t. Find the displacement of n at time t. Okay. Okay. I'm going to check the question now to see if I've got all the information from the question. At time t equals 0, n is stationary at the point P. So that's what we wanted, didn't we? Which I didn't write down, I don't think. So at time t equals 0, n is stationary at the point T. at P, stationary, there we go, at P. So, okay, so when t equals 0, v is equal to 0 because it's stationary. So these initial conditions then give 0 is equal to, this is 3t squared, that's 0 plus k. So that tells us that capital K then, the constant of integration is 0. So we've got velocity is equal to 3t squared then. Okay, so we've done that. Find the displacement now. So integrate again, s is equal to 3t cubed, raised to the power by 1, divided by that number, plus a constant of integration again, k dashed. Now s, the displacement, at time t equals 0, n is stationary at p, so the displacement is 0 when t is 0. S equals 0 then, gives, so 0 equals 0, plus k dashed, so that tells us that k dashed equals 0. So s is equal to, the 3's cancel, we just get t cubed. Okay, so that's that then. We've done the displacement. Find the distance mn at time t equals 5 seconds. So this is part, that was D. This must have been C up here, mustn't it? So E then, distance mn at time t equals 5 seconds, E. Dist n is equal to, well, the distance of n is t cubed. Distance of m is given by this, t squared plus 6t. T squared plus 6t minus t cubed. When t is 5 we get 25. Plus 6 5s. 6 5s are 30. Minus 5 cubed is 125. So we get equal to, the distance will be the modulus. So put a modulus around it. 55 minus 125 is minus 75. So it's a distance of 75 meters. Okay, so that's the distance. Find the value of t. What t is greater than 0 when the two particles meet. So this is f. Here, t squared plus 6t. It's a distance from p of the one. The distance from p of the other one is t cubed. So that tells us then, that t cubed minus t squared minus 6t equals 0. Divide by t all the way through. T is bigger than 0. We get t squared minus t minus 6 equals 0. Factorize. T and t, isn't it? And 3 2's. Minus t, so that'll be a minus, this will be a plus, so t squared minus 3 plus 2 gives minus t, plus times minus is a minus, 2 3's are 6, that's fine. That tells us that t must equal 3 because t is bigger than 0. And there's the time, t is equal to 3 seconds. Yep. So just one tiny change here, I've just looked through, double checked it. We've got 55 minus 125, I've decided that's 75, and it's clearly a difference of 70 meters.